In this lecture, we will continue our discussion on lists.
There are additional methods we can use for lists. Now, we're not going to be able to go over every single one, but there are a couple more that I do want to mention. One method we can use is called the remove method. This one's pretty straightforward. What we're going to do is we pass some item as a parameter for this method, and we just remove the first occurrence of the item. The reason why I say the first occurrence is it's possible for a list to have multiple items of the same value. So what this will do is it'll search for the first one that appears in the list and then remove it. This method does return true or false. So if it does find the item and remove it, then that means it returns true. If the item does not exist in this list, then it's going to return false. A variation of this method is called remove at. Now, the way this works is instead of removing a specific item, we remove an item at a specific location. So we pass an index, which would be the location in our list, and it'll just remove whatever is at that particular spot. I should mention with removing, just as how we would make room if we insert something in a particular spot, we would close the gap if we remove something. So for example, if we remove something at index 2, if there was an item at index 3, it gets moved over to index 2, and then we just shove everything accordingly. Another method we can use is called the sort method. And this just simply sorts all of the items in the list in increasing order. So that's from smallest to largest. The next method we'll look at is the remove all method. Now, I'll warn you that the way we execute this method is going to be very different from what you've seen so far. The idea with this method is we're going to look at every element in the list, and we're going to remove all the elements that match a specific condition. And this condition is going to be determined by what we call a predicate. So think of the predicate as a delegate to a method or a function. We're going to see some examples of how this works, but we're basically saying that we have this function or method off to the side that's going to return true if the object that we pass to it matches the condition that's defined in this delegate, and it's going to return false otherwise. Another way you can think of it is for each element in our list, we're going to compare the value of that element with our predicate. And this predicate is defined in another method. If the condition is met, so if the item in our list satisfies that particular criteria, then we just remove the element in the list. So the idea is check every single item, see if it matches some condition. If the condition is met, we remove the item. Let me give you an example of the predicate function first before we deal with the remove all method. So the idea is we're going to create a separate function that's going to return true or false. And this method or function is going to have some criteria. So maybe, for example, we want to remove all of the elements in our list where the value is equal to 6. So we could have a function like this. So we have private function equal to 6. We pass an integer as a parameter, and the function is going to return a Boolean, because we see that with our function definition, we say at the end as Boolean, which is specified right here. And if we take a look at our function, all it's doing is returning whether or not n equals 6. So if n equals 6, this is going to return true. If it's not 6, it's going to return false. So we're just checking to see if the argument that is passed into this function is in fact 6. The next question we have to ask is, after we create this function, how do we use this function with the remove all method? Because we're trying to specify this criteria, and we really haven't seen a case where we can use a function as an argument or a parameter for another function. Well, we can do it, and the way we go about doing it is using what's called the address of operator. So what this does is the operator actually creates the function delegate that we were talking about before. This delegate would point to a specified function. So the delegate is not the function itself, but it's kind of like a reference to that function. So the format of using the address of operator is we would have the word address of with the A and the O capitalized, and then we would have the name of the procedure right afterwards. Just the name, no parentheses, no parameters, no arguments, just the name of the function or the method that we are using that's going to serve as our delegate. And the idea with this is we can use the address of operator to refer to a method. So it's not like we're dealing with the method directly, it's more like an indirect way of using a method. And the idea with this is if we do end up calling that function delegate, it actually calls the specified method. You might be thinking, why even use that? Can't we just use the method directly? And what we will see is when trying to use functions as arguments, we can't. But we can use delegates of functions. So that's where this comes in handy. There's also some other situations where this is useful. So we can use this if we want to add an event handler for a specific event. So we'll see some examples, or at least one example later on of how we would do that. But the main use that we're looking at right now is that if we need to pass a function as a parameter, we can use the address of operator to take care of that for us. So how do we actually use this address of operator for our lists? Well, remember that the remove all method, so we're going back to that as our example here, it's going to let us remove all the elements in the list that meet some criteria. And in this case, in our example, the criteria is going to be determined by our equal to 6 function. So if a specific element is equal to 6, this function is going to return true. And if it's true, then according to the remove all method, we need to remove that particular item. So if we're going to make the remove all method work, it actually requires a function delegate as a parameter. Not the list, because we're invoking on the list, but the argument has to be a function delegate. In order to use a function delegate, we have to use the address operator. There's no other option. Here is an example of using the remove all method with the address of operator. So our first line is we create a list of integers. So we have dim sl as list of integer equals new list of integer, and we're adding several items here. So we got a 6, -7, an 8, another 6, a -7, and then an 8. And then we call the remove all method. And take a look at what we have inside the parentheses right here. So we have address of and equal to 6. So this means that we're going to create the function or method delegate that's going to point to the equal to 6 function. And we're going to pass that as our argument for the remove all method. What this means is for each element that is in our list SL, if equal to 6 returns true for that element. So think of this as looking at each element in the list and passing that specific value into equals to 6, or equal to 6, I guess. So think of it that way. So if this function returns true, then we're going to remove the element. So if we look at our example here, our list right now is 6, -7, 8, 6, -7, 8. What's going to happen after the remove all method is done is all the 6's will be removed. So that means our final list here would be -7, 8, -7, 8.